Hello, I'm Eli Hertz, and today I'm going to be talking about exponential functions and exponential relationships. So, what makes something exponential? I'm going to give an example situation. Let's say I have a plant, and this is obviously really unrealistic, but let's say I have a plant, and I plant it, and it starts at, 1 foot tall. Actually, let me write that bigger so you can see. Let's say if I have a plant, it starts at 1 foot tall, and it's a magical plant, and what it's going to do is every day it's going to grow twice in size. And so day one, right, or actually I'm going to make this a little bit easier. I'm going to call this day 0. So day 0, it's at 1 foot tall. And so next I want to go to the second day. So day 1. And so it's going to be 2 feet. And each consecutive day, it's going to multiply by 2. And so we can model this by graphing. And so I'm going to plot a graph here. I'm going to say this is the number of days. And actually, I'm going to say days since I planted this. And then on the other side, I'm going to have the height in feet. And so, right at 0 days, since I planted it, aka the day that I planted it, it's a magical plant, so it can do that. It's kind of the best metaphor I've got. And so it's at 1 foot. And then 1 day has passed, 2 feet. 2 days have passed, 4 feet, and so on and so on. And we can actually model this with a graph. So that's what I'll draw out right here. I'm going to do 2 variables. I'm going to say t is the number of days. And I'm going to say h is the height. And feet. I'm not going to write feet because it's kind of taken as an assumption. And I'm going to make a graph like so. And so I'm going to plot height versus time. And I'm going to make a little increment. So this is 0 days, this is 1, this is 2, this is 3. And then obviously I have 1, 2, 3, 4, 5, 6. And it'll keep going on. So if I start at 1 feet tall or 1 foot tall, then I go 1 day, I multiply that by 2, and I get 2 feet tall. And then after 2 days, so I go from day 1 to day 2, and I multiply that by 2, so I go from 2 to 4. And if you continued to plot this, you would get a curve that looks sort of like this. And it would just keep increasing and increasing and increasing like that. And that's what an exponential function is. It's a curve that has a common ratio that it's multiplied every increment. How can I actually plot this? So each day gets multiplied by 2. I'm going to plot this. I'm going to write it like this. H of t, that's just the height as a function of time, is equal to 2 to the t. So this is how an exponential function looks. You're going to have some value a is just a variable, and you raise it to your independent variable, and your dependent variable is going to depend on that. But that's what an exponential function is. It's just each increment that you go, you multiply by a certain amount. In this case, we multiply by 2 each time 1 increment of time has passed, 1 being 1 day. Now, let's say I have a different plant, and this time it each time half a day goes by, it multiplies by 2. Originally, our graph, you started at 1, it looked like this. But if it multiplies by 2 each half day, it's going to grow a lot faster. And so our graph is going to look more like this. You know, at some time t, we just draw a vertical line right here. Obviously, the one that grows faster is going to have a much higher value than the one that grows slower. It's just more vertical on the graph. And that would be called a transformation of an exponential function. Specifically, instead of growing every day, it grows every half day. And so what you would actually write for this instance is h of t is equal to 2 raised to the 2t. That means 1/2. So when you plug in a value for t, you obviously get a height. For here, let's say I plug in 1/2 day, that's going to read as 2 to the 1 day. Right? If this t right here equals 1 day divided by 2, you multiply that by 2 from the 2 t's, and these cancel out, and you get a day, right? And so you get back to the original curve, it's just growing faster. So that's what you would call a transformation, is you can put some value into your exponent. So in this case, we have 2 to the 2t. And more generally, this would be written as, you know, h of t equals a. This number a is what you multiply by each time. We call that the common ratio times, a raised to the bt, where b is kind of like what I was just talking about, where it grows every half day, or, you know, it could grow every quarter day or something like that. It's just something that transforms the function. And actually, if you think about this, let's say instead of growing every half day, it grows by 2. It grows by 2 every 2 days. Then it would be 2 to the t divided by 2, right? And so after 2 days have passed, you have 2 days, I'll just put d for days. You divide by 2, that cancels and you get a day. But that's really the basics of how exponential functions work. And yeah, if you have any questions, let me know in the comments and I'll be happy to answer them. Anyways, thank you very much for watching. And this is Eli Hertz signing out.